Right. So this project, it's a 3-year project, but started last year. Okay, so the data I'll be presenting to you guys today is going to be just from one winter of overwintering queens in bank colonies. And we have 2 more winters to go, which is actually, it's a really exciting time for this project because it's evolving, we're learning a lot, and we're getting a lot of input from beekeepers, which we can then apply to this project still. So we're in a really nice spot, an exciting spot, I guess, in this project. Yeah, so first, I'll kind of go through the introductory kind of portion, why we had even decided to look into this technique. Going back to my days working for the Bee Informed Partnership, this is a pretty well circulated graph. If you guys have ever filled out this survey, I applaud you. This is data from the Bee Informed Partnership Colony Loss and Management Survey that happens every year. And over time, we get a lot of data, and it quite often looks like this. This is a graph from the 2016 data, but it is pretty consistent that one of the top contenders or one of the top contributors, I should say, to colony loss is queen failure. It's queen failure. And that is across all, different just commercial beekeepers and also backyard small scale beekeepers. So what do we do as beekeepers when we have a failing queen or when our colony goes queenless? We need to replace that queen in the colony. And it's easier said than done quite often, right? In order to have, a kind of assurance that you'll be able to correct failing queens or some kind of queen event, you need ready access to queens, to some kind of queen to replace your colonies, to replace your failing queens. Okay, so that's the main issue at hand, right? We have an issue with queen supply, and I'll go into that a little more here. We did a survey, this is last year. We talked to a lot of beekeepers in Oregon and also in Idaho and Washington. And a lot of our beekeepers, commercial sideline or backyard beekeepers, rely quite heavily on a queen producer to purchase queens. And so in this particular graph, we're seeing that the majority of these beekeepers are purchasing more than 50% of queens that they need every year from a queen producer. Not only that, so we have this high demand for beekeepers in the US for queens from these queen producers. We have a high demand in Canada, right? The top queen producing regions for Canadian beekeepers are in California and Hawaii. Right? It just adds more to the demand for queens. And going over what you can basically group queen producing areas in the US into 3 different regions: Hawaii, California, and then just southern states. In Hawaii, you have, they sell mostly mated queens. It takes 2 days to get to the mainland, shipping wise, at least. And the earliest you can get queens is in February. That is by far the earliest you'll ever be able to get queens, right? Because Hawaii is by far, it has the longest and earliest queen season in the US. And then we have California, like where you guys are. Again, most of the queen producers are selling mated queens. And we start seeing the first mated queens available in March from California. And then we have the southern states. And the southern states produce a lot of queens as well. And they produce more queen cells for purchase than any other region in the US. They also will produce mated queens for sale too. That also happens in March. And another concept that's I'm kind of building up to this issue of queen supply here. Another concept that really shaped this project was the almond pollination, right? It is by far the largest pollination event in the country and in fact, probably in the world, right? You have a lot of acres that require a lot of colonies. And another kind of set of really big issues with almonds is that they bloom really early, and a lot of the pollination contracts for these beekeepers that are renting their colonies for pollination here is they require a pretty sizable colony, an average of 8 frames of bees, a minimum of 4 frames of bees. An 8-frame colony that in February is, I mean, it's unseasonably large for any U.S. colony, or at least the ones coming from Oregon, right? So when you think of the queen supply issue of beekeepers that are detecting queen failure, failing queens, queenless colonies, there's not a lot of time between when they come out of their dormancy period in winter and the time they get graded to fulfill their commitment to these pollination contracts. That's basically the month of January and early February, where beekeepers can really react to queen issues in time to have an adequate pollination unit in almonds. Okay, tying it all together here. This is a purely hypothetical curve, both of these curves, a supply and a demand curve. This blue line represents what the theoretical supply is of queens, as we, this is grouping in all 3 of those regions that I discussed, right? So in Hawaii, you start to see, queens coming in February. And then it kind of grows, that supply grows quite a bit starting in March. We have queens coming in or queens available in California and the southern states after that. Okay, and you have all sorts of really high queen production May through July, and then it tapers off towards the end of the season. Now, when we look at the theoretical demand, we have a huge, huge demand right at the time of almonds. Right. And so you have this clash, you have this extreme demand not being met by the actual supply of queens in America in basically January through March for the almond pollination. Another thing I want to point out here is looking further down into the later season in July, you have a shift that happens starting in late June. You do have a bit of a surplus of queens then. A lot of queen producers will reduce or even quit their queen production at that time because it just gets so hot, especially in California. But you do have a little bit of surplus that happens later in the season. And so that's where our idea stems from. The goal of this project is we want to have some kind of solution, or at least a partial solution to having more early season queens available to beekeepers that are pollinating almonds. And so our idea is, let's have Oregon beekeepers overwinter late season queens that they purchase from California producers and overwinter them in Oregon in bank colonies, and then transport them to the almond pollination. Thinking about the different kinds, the different ways that you can overwinter queens, there are 3 ways. The first, probably most popular that I've seen in Oregon, is you can overwinter queens in nucleus colonies, right? In 5-frame or 6-frame nukes. If you're a queen producer and you have mating nukes, 2-way, 3-way, even 4-way mating nukes, you could also overwinter queens in those little mini nukes. And then lastly are overwintering queens in bulk, right, in bank colonies. Okay? And if the major difference between these three methods are completely viable, but you are contributing a lot more resources, so a lot more bees, brood, food, a lot more inputs into a 5 or 6 frame nuke compared to a bank colony, right? Overwintering 100 queens in 100 nukes is gonna require a lot more inputs than overwintering 100 queens in, 2 or 3 banks, right? So narrowing in on queen banks. It is, in just a brief definition, a queen bank is a living incubator. You put a bunch of caged queens in a banking frame, suspend that frame in the center of a colony, of a bank colony, and those queens will be cared for from the worker colonies in that bank colony, right? Very basic definition, but it's more complicated than that, as you probably were expecting. We at OSU have a fair amount of experience banking queens during the field season. A lot of beekeepers do this. Field season banks is probably what I'll refer to them most as. They are actively managed banks. Okay, so we have a few that we run every year at OSU. And I want to point out that quite often I'll hear beekeepers be really hesitant towards keeping queens in bank colonies for very long. They want to get them out as soon as possible. And I think that I kind of challenge that. I challenge that statement because I do think that it is, if they are properly managed, a bank colony can bank queens for a really long time, right? A high quality bank. And I can speak from experience. I've had at least 7 years at OSU. We've successfully banked queens all season long, which in ours, from April to September, that's a 6-month period. So you can do it. It's possible. But you do have to properly manage them. And we've learned some things along the way of how to maintain field season banks or actively managed banks. Okay. First and foremost, the bank colony has to be queenless. So the bank colony is full of queens, but it doesn't have a laying queen present. Next, another really big recommendation is that the queens that you bank should be the same age. We have the idea behind this is that workers will prefer older queens. So if you're allowing queens that are older and younger in the same bank colony, you do risk lower survival of your banked colonies because there is a preference there towards older queens. That is piggybacking off of that concept. I definitely recommend that you try to find a different home for the resident queen in a bank colony. Resident queen meaning the queen that you remove from that bank colony if you are in fact choosing a colony that's already established, as opposed to making it up from bulk bees or some kind of queenless package or something. Okay, so the reason why I don't like beekeepers using a resident queen and putting that resident queen in your banking frame is she is almost 100% a different age than the queens that you want to bank, right? Most likely those queens are an incoming shipment from a queen producer, or they're queens all from the same catch if you raise queens yourself, right? Another big concept is you want a lot of bees and you want a lot of them to be young. You want a lot of TLC, going towards your queens, and that's going to be best achieved by young workers. And so in order to get and maintain this, lots of young bees that you have in a queenless bank colonies, you have to be pretty diligent about adding young bees, and that's either in the form of brood frames or of installing young bees, bulk bees, periodically throughout the season, throughout the time that you have your bank colony running, maintained. The last thing I'll say that we've learned is that it might be a good idea to avoid keeping your bank in one of your mating yards, because you run the risk of having a virgin fly, drift, and instead of flying into her resident mating nuke, she flies into the bank colony. And there's a lot at risk there with the bank colony, because you have a lot of queens in that one colony. So if you have a virgin that that somehow makes her way into a bank, you might be in trouble. You definitely risk having those queens killed. So I'm going to go by just a real briefly the step-by-step process about how we make up banks, field season banks. Okay, the first step is we choose an established colony instead of making one up from donor colonies. So we choose a healthy colony, so it's big, it's clean, and by that I mostly mean mite-free, varroa mite-free, and it's heavy. It has a lot of honey and it has a lot of pollen, right? A nice, healthy colony. Then we remove that queen and we wait at least 15 minutes. So we have that colony be queenless for at least 15 minutes before we introduce any of the banked queens. That is enough time, 15 minutes is enough time for them to realize that they are indeed queenless. We have also waited 24 hours, or just, kind of returning the next day. We'll remove that queen the day before we get our queen shipment, for example. And if we do have that kind of a longer period of time like that, that they are queenless, we put in a synthetic queen pheromone, temp queen is a trade name of that. And that just keeps them calm. It also, we believe, reduces drifting that would happen in a queenless colony. So that's another tip if you make up your bank colony the day before. The next step would be placing your banking frame of queens, and you place it in the center of your colony. If you selected a double story colony, a double deep or a deep and a medium, you would put that banking frame in the top box, centered. Step 5 is very critical. All of these steps are really critical, but I'm emphasizing step 5 because this is where I see a lot of problems happen when I talk to beekeepers about their bank colonies. You really need to make sure that you don't have emergency cells. You don't have, a virgin that hatches out. And even though you introduce a bunch of queens into that bank colony, they will most definitely, most of the time, they will draw cells, emergency cells in the existing brood that they have in that colony. So I recommend that you go in, inspect the brood twice within 4 to 9 days from the day that you removed the original queen. And I prefer to shake all the bees off of that brood frame and look. That way you don't have any queen cells that are hiding from you. So I'll do that, and I'll do that twice. Right, and so I really, really want to make sure that I get all of those cells cut. And then the 6th step is specific to long-term banking. You want to maintain again, that young worker population. So you want to keep adding brood frames, or if you have the ability to make up some bulk bees or make up packages, if you have a shaker cage, for instance, you could add, a couple pounds of young bees. And we like to do that every 2 weeks. That isn't rigid. You could do it, every 3 weeks or something like that. But those are the 6 steps to how you make up and how you manage a field season queen bank. And that's important. All of the reason why I'm going through all of this is that all of these concepts, all of these tips are also translate to how you want to make your bank up if you want to overwinter queens in a bank. So now we're merging into the concept of instead of an actively managed field season bank, we're thinking about this concept of making up a bank to go into the winter dormancy period with all of these queens. And this isn't a new topic. There is a lot of research that has gone into this technique, the majority of which is in Canada, because they, I think mostly because they have just their queen supply issue is a pretty big deal there. They are very, very reliant on outside queen producers. And they also do not have a good climate, a good mating weather climate, unlike us and yourselves in California. The original work was done mostly in the late 80s, early 90s in British Columbia. And we have an uptick in revisiting this technique. Yeah, it's a pretty trendy technique to be looked at right now. We have people in Ontario, Quebec, like British Columbia, that and even Washington State. Brandon Hopkins is also looking at this here. They're looking at this technique and again trying to perfect it really for their specific regions. I also know a fair number of California queen producers in Northern California that will overwinter queens in banks. Those of which that I've spoken to actively manage their banks throughout the winter. They can do that. Their winter temps are warm enough. So that might be something that if you guys are interested in actually banking queens in the winter, you might be able to get away with just actively managing them throughout the winter. And you might have better luck than what we do in Oregon, which is just prepare them for winter and then see what happens, see what comes out in January. Yeah. All right, so things that we know for sure from this previous research of overwintering banks, we know that you want to get the timing right. You don't want to put your bank together too early because you want to make sure that those bees are winter bees, diutinous bees, right? And so we have I'm drawing from 2 different studies when it comes to, when are winter bees raised? We did our own 3-year study at OSU and found out that most diutinous bees, winter bees, are raised between early September to late October. And then you also have a repeat. You have a study done in Ontario early on in the early 2000s, and they found that you get most of your winter bees in Ontario between late August to early October. I can also speak from experience at OSU. It's data that's not presented in this talk, but I have started banks intended to overwinter the first week of September with great success. So I probably wouldn't go any earlier than that though. So getting your timing right, also making sure your colonies are ready by the time you make up your banks, right? Getting your mite treatment on and getting your mites under control in particular. Yeah, and also making sure they have a lot of food stores. So there's a heavy emphasis on having them heavy with a lot of honey frames, but also what has kind of popped up in discussions with other groups that are looking into this, are looking into banking, is that the amount of pollen in banks also plays a really big role in overwintering queens. All right, so, and what am I'm like 20, 30 minutes in. Now I'm actually introducing the study. We have three main objectives that, and like I said, it's over a 3-year period that we're trying to accomplish these objectives. First and foremost, it's just evaluating queen survival for this technique for overwintering queen banks in Oregon. And we're looking at different operations in different different regions of Oregon. And then kind of getting a little more specific, we want to evaluate the banking effect on the queen quality, specifically the reproductive quality of those queens. And also we want to evaluate queen performance. An incredibly interesting part of this study, right? We want to look at how banked queens that overwintered, how they compare to Hawaiian queens, because that is for most of the Oregon beekeepers that we work with, that is their option that's available in the spring during almond pollinations. That acts as a control, really, Hawaiian sourced queens. I gotta move this. Sorry, I gotta move this chat bar. So, okay, so I can read my slides. Okay, so for objective 1, we're looking at 3 different beekeeping operations, each overwintering their colonies in very different parts of Oregon. For each operation, or each location, they are overwintering queens in 5 banks, and each of those banks have 20 queens. In addition to banking queens, we had control colonies. We introduced sister queens from this queen producer that that we banked, that are going into our bank colonies. We also introduced those queens in 32 control colonies. So we take some of the banked queens and some of the control queens after they overwinter, and we send them to North Carolina State University, David Tarpey's Queen Clinic, to look for morphometric and reproductive quality measures, right? We're comparing the two. Fully established colonies, queens that are in fully established colonies, and queens from banked colonies. Okay, and our third objective, which I don't have a lot of data yet, is evaluating the queen performances over time. So we install them in nukes. They are currently in double-story colonies about 30 minutes from Corvallis here in Oregon. All right, really diving into the details of how we set up our banks. These are, again, they're not field season banks. They are banks that are intended to overwinter. We worked with each beekeeper, and they took us to one of their higher performing yards, and we looked at their biggest colonies in that yard. Okay. And going off of that strategy, the bank colonies that we selected, the largest colonies in a high performing yard for each of these beekeepers. This is in September and early October. The colonies were between 14 to 19 frames of bees, so big, beefy colonies. We also made sure that there was at least 70 pounds of honey, so at least 7 full frames of honey in the top box. We made sure they were queenless, right? So we went in and we found a resident queen and we removed her. And then we made sure that we cut cells. We meticulously cut those cells, just like what we do with our field season banks. focusing on the actual banking frame design, right? The banking frame is what holds all of the queen cages together. This is a double frame, meaning that it takes up the space of two Langstroth frames. And what we did is we're doing 20 queens per bank, or we did. And we have them, you can see these in these pictures, they're dummy cages, or at least the one on the bottom left here. We put these in colonies earlier in the season, and we had bees draw out comb around all of the empty spaces in the bank frame. And for the most part, they filled up that comb with honey, right? We wanted those queens to be surrounded by comb and also by either honey or open nectar for an insulative factor. So we started prepping, in June of that year to get all that comb drawn out of those banking frames, intending to then, overwinter those queens. Looking at the 3 different locations that we overwintered in, the first beekeeper number 1, I'll refer to this beekeeper as beekeeper number 1, is in the Willamette Valley, really close to where we are in Corvallis. And then we have 2 beekeepers that we worked with in Eastern Oregon. And if you guys have ever traveled to Oregon, it's an incredibly diverse state. You have the Willamette Valley their winters are wet and rainy, pretty mild temperatures, but then in Eastern Oregon, you have a lot of snow and you have cooler temperatures, dry, cool winters. The difference between beekeeper 2 and beekeeper 3 is that the 3rd beekeeper overwinters their colonies and also the banks that we worked with this beekeeper on in indoor storage. So this is a forced air indoor storage unit that is quite common in Idaho and also in this particular part of Eastern Oregon where this beekeeper is, right? So 3 very different overwintering locations. Even though they're all in Oregon, they're different. I'm going to go through some temperature data with you. I'm not going to dwell on it very much. And I realized right before I jumped in on this Zoom call that this is the first US talk that of this project that I've had. So unfortunately, these next 3 graphs are all in Celsius. And so I apologize. But I'll do my best to kind of generalize how hot and how cold it was. For the Willamette Valley region, for the beekeeper number 1, we put the schedule of how we made up these banks and how they went through the winter is kind of spliced together in this schedule up top here. We made up those banks, put those queens in those banks on the 3rd week of September. And then in mid-January, they traveled to California. So there were 18 weeks where they were in the Willamette Valley in these banks. And in general, we in the thick of winter, right? So November, December, January, there were highs within the 40s and 50s Fahrenheit, and then lows of around 20 to 30 degrees Fahrenheit. Okay. They were in California mid-January. We took some queens for analysis for David Tarp for the North Carolina State University's Queen Clinic the 1st of February, and we didn't introduce them into nukes until March 10th. Beekeeper number 2 follows a really similar schedule to beekeeper number 1. We started those banks a little later. So they only overwintered in Eastern Oregon for 16 weeks, and it is a bit cooler. I would say not by much, though. It was a pretty mild winter in general, both in the Willamette Valley and in Eastern Oregon this past winter. I would say in general, the highs were around 30 to 40 degrees Fahrenheit of highs and lows of 20 to 30 degrees Fahrenheit. Okay. Beekeeper number 3, again, you have this added factor of overwintering bees in indoor storage. But what's quite common for beekeepers in Eastern Oregon and Idaho is that they don't go into storage for very long. We established those banks in early October, and they were outside for 9 weeks. And then they went into storage for 7 weeks. They come out and go immediately to California. So anyway, yeah, and that part of Oregon is the coldest. Okay, I would say we had highs of about 20 to 30 degrees Fahrenheit and, lows of 10, 15 to 20 degrees Fahrenheit. Okay, so just to put these locations in context, that's the temperature data. We also had a fair amount of trouble that happened in the fall. I mean, I'm not even including all of the COVID-19 travel restrictions that we had to do with OSU. We had a lot of wildfires in Western Oregon, a lot of them, which delayed a lot of our work. We also experienced a lot of robbing. Having a colony open for that long to find and locate the queen in a fully established double-story colony, and doing that for, you have 5 banks plus 32 control colonies. Having that, it caused a lot of robbing. So that's where we actually put some wet bed sheets on some of our colonies, which actually really helped out a lot with our robbing issues. So we got through it. We got through the trouble. So this is going to be pretty data dense. These are our survival percentages. For beekeeper number 1, this is the Willamette Valley. We had an average of 86% survival. Okay. We started out with 100 queens, right? 20 queens in five banks. We looked at queen survival the 7 to 8 days later. That's when we went in to cut cells. And in our instances, although I had recommended previously to cut cells twice, we only had the option to cut cells once. So we only lost 1 queen within a week. In some cases, we had extra that we added, and that's in the case of beekeeper 2 and 3 that happened. So we lost a few, I guess, in that 1 week period, right? We lost a fair amount with beekeeper number 3 right in that 1 week period, and I'll get to that, why that happened. But then you can see the majority of the queen loss happens when they're actually, just further down the line. We opened them up to look at them, at least with beekeeper 1 and beekeeper 2, before they went to almonds. And, we're sitting now at 86 queens and 81 queens of those 2 locations, which we did not lose any queens in transit when they were loaded onto semis and went down to California, which was interesting to see. Then we get to beekeeper 3, and the number of queens that were left, we were not able to actually check the queen count before they went down to almonds because they immediately come out of sheds. But we only had 37 queens left, which is a big loss. It's a significantly lower survival rate than the other 2 locations. So that's interesting. And the ranges are also in parentheses. We had 1 case where we lost every single queen out of the bank, but we also had 1 case where we had 100% of the queen for beekeeper 1, 100% of the queens survive in a bank. Lots of variability right off the bat here. And just to give you the stats about the control colonies, this is interesting to some beekeepers because in conversations with some, they hesitate with requeening fully established colonies at any time of the year, in spring or in fall. We had an incredibly high survival rate. We were all able to introduce new queens in late September, early October with no problem. We had more than enough to sample for what we were trying to do. Honing in on beekeeper number 3, because this particular location did so poorly. The first situation I want to point out is the fact that we went from 100 queens introduced into these banks to, when we went back about a week and a half later, we only have 88 queens left. A lot of that reduction happened because one of those banks had a laying queen in there. So what most likely happened is that that colony had 2 queens present. I see that every now and then. There are just some colonies that have 2 queens, and they are perfectly happy with each other, at least at the time that we see them together. Quite often we'll see them on the same frame, but this time we did not see that second queen. We saw one queen, remove that queen, and we thought that that was then a queenless colony. So when we came back, 7 to 8 days later to cut cells, 9 out of the 20 queens were dead, right? It further supports the fact that you absolutely have to have a queenless colony to have a successful bank colony, okay? But there, we were thinking about the other things. How did this particular location differ from the others? When we looked at the banks that came out of the sheds that were in almonds, they were big, they were heavy. So that was a bit puzzling. One thing that, we took mite samples at the time that we established these banks, and 3 out of the 5 banks had what I would consider to be high mite levels: 0.7, 2.6, and 3 mites per 100 bees in an alcohol wash. So moving forward, I do think we need to focus on having virtually no mites in the banks. I looked at a couple of the tarsi of the dead queens that were found in these banks, the feet, the queens, and they didn't appear to be chewed. And so it's quite possible that because of that, and it's possible they died by abandonment instead of by aggression from the worker colonies or from the worker bees. Unknown variables is we do not know the survival loss that happened when they went into indoor storage. We also don't know how much was lost in transit. So we do need to record more survival intervals, which is, it's more difficult when they're really far away, like where this particular location was. But we do have to, that has to be a solution we need to implement into the next couple of years, is we need to, that'll help us pinpoint exactly where the problem is. It's gonna turn for me, okay. All right, so going to our second objective. So we sent a sample of these queens from each beekeeper to David Tarpey to look at morphometric measurements and reproductive measurements. All 5 are listed here. Excuse me. We did not see significant differences between the beekeepers or between the control and the banked queen samples from head width, thorax width, or total sperm count, but we did see differences in body weight and sperm viability. This is body weight. We found that the control colonies in beekeeper number 3 were heavier than all banked queens from all 3 beekeepers. If that makes sense. And it kind of, I'm not surprised by banked queens weighing less or being smaller than free roaming queens. This is an interesting one. We did find that there was no difference in sperm viability in the control and banked queens in the relatively successful locations, beekeeper number 1 and beekeeper number 2, But when we look at beekeeper number 3, there is a significantly lower sperm viability rate in banked queens than the control queens with beekeeper number 3. So that's interesting. So it is something where, if quite possibly, if you have really, you could tie in, the higher loss rates to also potentially lower quality banked queens coming out of those banks. For our third objective, which is ongoing, so I don't have a lot to report on. The first thing, I'm jumping ahead of myself really. The first thing we had to do is we had to have these queens survive from the time that they arrived in California to the time they were going into nukes for evaluation. And so we employed those managing techniques that I discussed earlier, right? We're introducing frames of brood or young bees, in our case, frames of brood, every 2 weeks, and we're diligently cutting cells of those brood frames that we've been adding to those banks. And so we introduced 2 full frames of brood. That was just an arbitrary number that I thought was a good number of bees to introduce and keep those bank colonies strong. And we looked at frames of bees. We did have some beekeepers express some interest and more concern really in having these bank colonies be rentable units in almonds, right? Again, going back to this idea or this requirement in your pollination contract that you need to have a minimum of 4 frames of bees and an average of 8 frames of bees within the orchard that you have your colonies in. And so this is just a graph of the 10 banks, 5 from beekeeper number 1, 5 from beekeeper number 2. The banks from beekeeper number 3, we are basically dropped from the study at this point because there were hardly any queens left. For the most part, they were able to maintain at least at some point 8 frames of bees, some of them, but others fell a little short. All of them at least maintained 4 frames of bees. So they were rentable units in almonds. Okay, now for some concluding remarks, which I feel like for the most part, there aren't very many concluding remarks because this is an ongoing project. But nonetheless, we saw a wide variation in queen survival rate. This is between beekeepers and even between the banks within each location. So that is something that we also see, we've seen with previous studies too. So really wide variation of survival rate. Another thing that was interesting is we saw no queen loss in transit from Oregon to California in the 2 beekeepers we evaluated, beekeeper 1 and 2. We saw some differences in reproductive measurements with queens. We saw some with queen weight and some with sperm viability. All the queen banks made at least a grade of 4 frames of bees throughout our time in almonds before we introduced them into nukes. And they maintained the minimum, but not all of them made the average grade of 8 frames per bees during their full stint in almonds. Dual colonies can be a problem. We have seen this in our field season banks too. And, again, drawing on that one situation with one bank and with beekeeper number 3. We also saw 2 control colonies also had dual queens, which contributed to some poor acceptance, right? So 3 out of the 113 colonies that we dequeened and requeened had a secondary queen in there when we came back and checked 10 days later. Another thing to note is some of the banks had very high nosema levels. Not all of them, but some of them did. The most extreme nosema level we found was 38.9 million spores per bee. That is by far the highest nosema result I have ever seen. But we didn't see any correlation to queen survival with this particular queen bank that had high nosema. That being said, we do question whether there are long-term effects that are associated with queens from that bank because of that super elevated nosema infection. All right, almost done here. We are evaluating the performance of the banked queens from beekeeper 1 and 2, and we are comparing them to Hawaiian sourced queens that were purchased on March 10th, early March. They were introduced into nukes at the time of March 10th, but are currently in double-story colonies here, just 30 minutes away from Corvallis. We have been evaluating them. We probably won't have data for this year until October. We're deciding to wait before we actually draw any kind of observational conclusions from our data thus far. So that is the update on our project. What are we going to do next? We are going to, when we're going to be making up banks this coming September and early October, we are going to follow a couple new guidelines. We're going to try to extract extra bees from donor colonies. We could do it by pulling brood up underneath an excluder, right? So with double-story colonies that are really big, we can put, a couple frames of brood over an excluder in a third box, and the next day we can grab those colonies those brood frames and install them into banks. We could also make up bulk bees with a shaker cage. That might be pretty difficult during the fall with all of the robbing that we've experienced last year. Yeah, the other thing we are going to consider is we're going to change our banking frame design. We have a new design that's going to be 3 rows of queens in a single frame. And we're thinking about overwintering, instead of 20 queens per bank, we're going to look at overwintering 60 queens and compare it to overwintering banks with only 30 queens, trying to up our sample sizes per bank to make it a little more practical for commercial beekeepers to justify a bank colony. And then another guideline we're gonna look at is we're gonna take mite samples again, but we are going to be more stringent about our mite levels, and we are only going to move forward with banks that have 0 mites per 100 bees before we install queens into them. Yeah. Thanks so much, guys. I hope I didn't go over too much. Might have been 45 minutes or so.
Perfect.
Closer to an hour. But if there is time for questions, which I hope there are, I'm happy to answer any questions that anyone has.
Excellent. Questions, anyone?
Yeah, I have a question.
Go for it.
I was curious, you never specifically spoke about mite treatments. Did you at any time during the banking treat for mites? And if so, what did you use?
That's a great question. For the fall, the mite treatments that were applied to colonies happened before we installed queens. This is for the fall. for these commercial beekeepers, right? We wanted to make sure that the beekeepers were satisfied with their treatment schedule before, we make up those colonies. However, in the spring, in January, apivar strips were put into bank colonies. It's a really common thing that beekeepers do at that time of year. It's an economical way of using apivar strips because you only have to use a few. Yeah, that brings up a good point though. At that time that you're making up bank colonies, you may feel like you still have to clean up your mites, right? So we made up our banks in late September, early October. You might still be treating your colonies at that point, especially in California, because you have warmer temperatures where you can, you have that extended treatment window. But it is, I think you have to be pretty cautious about applying chemicals right next to where all of your caged queens are. I'd be cautious about that, but I don't have data on how well queens do with treatment in them. Certainly any of the organic acids would be a big no-no for having a bunch of caged queens right next to the treatment.
And one last question. You spoke about the importance of having queens of the same age. So how did you actually go about for your study and sourcing the laying queens?
For our study, we worked with a queen producer in Northern California, and we asked to have sister queens all from the same round. And
Oh.
so he was able to do that. It's pretty easy if you say well in advance that you want them all from the same. You don't have to have them be sister queens. And by sister queens, I mean they're all from the same breeder. For our study, we wanted them all to be sister queens. But in the case of just overwintering in general, as long as they're all the same age, I think it's pretty easy for most queen producers, at least in Northern California, larger scale queen producers, to be able to give you a batch of all the same age. I think it's pretty easy for them.
Okay, thank you.
Yeah. Any other questions?
So Ellen, I'm wondering, you were talking about the robbing and the fire. How much do you think that the fires up in Oregon affected the robbing?
That's a good question. I don't know if they affected the robbing that much. I don't know if those two have a lot of synergistic effects really, but the wildfires were definitely, I mean, there was about 2 weeks where you couldn't really do a lot. At least from a researcher's perspective. I just had to wait, I mean, every beekeeper had at least some locations that were compromised where we were. And the 3 beekeepers that we were, beekeeper 1 and beekeeper 2 had to just frantically move bees out of compromised areas. And so that's mostly how it affected our study. But I honestly don't think that wildfires really directly affect the robbing intensity, because at that point when the wildfires came in, all of our nectar sources were dried up already. And so I could see that being the factor, if you had some big wildfire happen in the middle of your blackberry bloom, I could see that having a pretty big effect on robbing. But
okay.
Yeah.
Okay. Another question. I'm interested in your thoughts about bee storage, where the beekeepers are now putting the bees into warehouses. Because I don't know how long that's been going on, but I've been reading about it for a few years, and it sounds like the bees that went into storage didn't do well. And I wonder if there's a correlation there, or that you're thinking about.
Yeah, so it's been a long-standing practice for beekeepers in Idaho to do it, and for beekeepers in Canada, but it's becoming an increasing trend from beekeepers outside of Idaho to transport their colonies to Idaho to overwinter in sheds. Some beekeepers are even building sheds wherever they live, North Dakota, etc. There's a great resource for beekeepers through Project Apis M that recently came out, talking about all of the different caveats of overwintering your bees in indoor storage. But a really common thing I hear from beekeepers is that if garbage in, garbage out, if you put unhealthy, potentially compromised colonies into the sheds, that's what you're going to get out of sheds. So I think that that's just an example. There are a lot of factors that go into to the quality of what comes out of indoor storage units. That being said, too, you have to manage them differently too, and it's an increasing trend, but there is a good resource out there for beekeepers that are doing it. Yeah, I think for the most part, I've seen really, really good bees coming out of indoor storage based on experience sampling all colonies of the Northwest, all different types of overwintering. So, but also I'll say one more thing. It is, as a commercial beekeeper, it is a risk too. And it's kind of like banking queens. You're putting a lot of your eggs in one basket too. You're having them all in 1, 2, or 3, depending on how big you are, indoor storage units. And that can be pretty scary too. Hopefully your temperature is regulated, because if you get all those bees in one spot, I mean, it can get really hot unless you have, a properly operated facility that's keeping that cool air circulated. So.
Because one of the things I read about it early on was the idea that you put the bees into storage places like that, and then you control the temperature. So basically the bees go into this sort of like, I don't know what you would call it, this kind of trance. They're in this low level. They're just kind of existing and not burning a lot of energy, which kind of seems counterproductive to taking care of the queens.
Oh, maybe so. Well, they go dormant, and it actually really depends. There are different types of indoor storage. Many facilities are just forced air storage, meaning they're just circulating cold air through. So it's providing a drier and, in theory, kind of a more regulated temperature environment than if you were to overwinter outside. But then you also have these refrigerated units too, which really controls the temperature. You even, in addition to that, you have CO2 regulated units, which I hardly hear of really, but could potentially be a trending indoor storage. So I guess my answer for you there is I think that it's pretty variable on, as is almost everything with beekeeping. Yeah, I do think though that being able to regulate the temperature has some pretty strong advantages. I stand by that statement.
I guess it's a standard answer. It just depends.
Yeah.
One last question for me. Do you think queen banking is something that practical for like a club like ours to do?
Well, I was thinking about that before I talked to you guys, because I knew that that you probably don't have very many commercial beekeepers that are part of your group. I mean, you're a small, you guys are mostly smaller scale beekeepers, and it's hard to say how practical having bank colonies would be. I guess, yeah, maybe something I was thinking of that could be advantageous, because you guys are in California, is you could, like, if you had someone who, or if you had some kind of group of beekeepers that were really into raising queens, you could bank them over the winter as part of some kind of queen cooperative that was part of your club. and you
Mhm.
could sell them for like a lot of money
Yeah.
at the time of Oregon, or not the time of Oregon, the time of almonds. That is
Yeah.
something that, you know, your particular location has a pretty strong advantage there,
Mhm.
you know, and also with your milder winter temperatures, you will likely have a decent survival percentages too, because I do think that the, you know, the colder, the harsher winters it is, you definitely run a risk of higher losses. So
Right.
something to think about.
Yeah, I
Yeah.
got a notice the other day from one of the people that they were selling queens for $62 a piece.
Wow.
It's like, wow.
Yeah.
I might want to rethink about that.
Yeah. Yeah, if you buy queens, like the commercial bulk rate that I'm aware of is about $28.50 per queen.
Mhm.
That's, you know, if you buy direct and if you buy in bulk.
Yeah.
And so you could absolutely sell queens for more to hobbyist communities at any time. And also to commercial beekeepers who really need it in almonds, you could sell it for a lot higher price.
Yeah.
But, you know, and this is another thing that we've been thinking about, is it economical? Like we know that, you know, beekeepers could sell their queens or could replace colonies that are highly valuable, you know, in January and February. But the amount of inputs that you put in and time to manage those bank colonies, is it worth it? We don't know. We would like to do an economic analysis on that. That's kind of one of our future goals with this project.
Mm.
There's a definite question whether it's economically viable.
That's a great point. This has been really interesting tonight because, you know, I go to my primary resource, YouTube, yeah, and everybody makes it look easy there. So,
Well,
yeah, feel
and
free.
yeah, there really isn't a lot of great resources out there for how to bank colonies.
Hmm.
And we intend to come out with a very concise and resource out there probably in 2022. We want to give it another winter so that we can be confident of the content that we put out. So when that's published, I will forward it to your group.
That'd be
And
great.
that can be a resource for you guys.
Good, that'd be great. Any other questions, folks?
Yeah, if possible, Ellen, thank you. Very interesting presentation. Three quick questions. First of all, on the bank queens, are they all artificially inseminated or are some naturally mated? And if there's a difference between them, does that affect anything? The second question, and you kind of just touched on this, I know you're going to be doing future stuff on the economics of this, but what's your hunch on the economics? And the third question, wonderful book. And I know you were part of a team on the Be Informed partnership. What was your contribution to this project? Because I've found this a very interesting read. Thank you.
Is that the commercial beekeeping guide?
Yes.
What is that? Yeah.
Yes, the commercial, but it's been
Okay.
very helpful to us just doing what we're doing. Thank you.
So yeah, just to answer your last question first, I wrote, I co-wrote that book with the rest of the tech transfer team people. It was a giant group writing project. Really excited to hear that you like it because we spent a lot of time on it. There's a lot of really quality content in there that doesn't only apply to commercial beekeepers. It's a great read for hobby beekeepers too. My specialties are in, you know, Varroa control, Varroa biology, queen production, and pollination. So that's probably where the majority of my input was for that guide. But yeah, anyway, that's a little plug for the it's commercial beekeeping guide. It's not a free resource. You do have to buy it, but it is it's something that I'm very proud of. One of the great resources out there. For the queens, so sister queens, they come from the same mother. So they come from the same breeder colony. You're grafting from the same breeder colony, but they're all open mated. So they're not 100% related to each other. And that is how most of the scientific studies operate when they are looking at, when they're looking for consistency, they shoot for sister queens. If you wanted to really control the genetics, if you wanted each queen to be 100% related to each other, they're called super sister queens, and they are all artificially inseminated with, so they have a controlled drone genetic source. Yeah. So the queens that we overwintered were naturally mated. They were just all from the same breeder. They all have the same mom. And then what was your middle question, your second question?
You touched on the economics, and
Yeah.
I realize you're doing future.
What's my hunch?
Yeah, what's your hunch on that? It seems like there's
So,
something to this.
yeah, the amount of variability is, I mean, it's not great that there's a lot of variability that we saw, but I don't want to, I mean, it's just 1 year, just one winter, you know. I would really like to see the results from 30 queens and 60 queens, banks with 30 queens in them and banks with 60 queens in them, because I feel like that is a much better, kind of from an economical standpoint, a better target to shoot for, to overwinter ideally 60 queens in a bank. And quite often, most of these projects that have been done only look at a pretty small amount of queens, 24 queens, 48 queens, you know. I think that shooting for 60 queens, seeing how they do over the course of the next 2 years, that I think will, it'll give me a better picture as to really how economical would it be for a commercial beekeeper to do it, or anyone really to do it.
Thank you.
Yeah,
Thank you.
no direct hunches yet, but
Okay,
that's
thank
my
you.
that's my answer.
Very good. Any other questions, folks?
Yeah, I have a question. So on the banking, do you put more than one bank frame in the brood boxes, or do you only put like one per brood box, or do you do 2 or 3? Because it looked like each one of those bank frames would hold probably, I mean, I'm guessing like maybe 20 queens or something like that.
Yeah, so and that varies, you know. I've seen a lot of queen producers, almost every queen producer has some kind of bank management, right, to hold queens in order to ship them out at certain times. So on kind of the extreme that I've seen, you know, you can hold 3 single banking frames in one bank colony. So a single banking frame quite often will hold around 60 queens, right? So I have seen, you know, 180 queens in one bank. This, of course, is in a double-story colony. It's really big. And you also checkerboard those banking frames with a drawn frame, a Langstroth frame. For OSU, we really don't operate. We manage about 80 colonies, you know, so we run about 2 to 3 banks at a time. They all have different ages, really. One of them is all of our super old queens, because we just feel like keeping them around, kind of. We kind of hoard queens a little bit. And then we have one bank colony that holds we requeen all of our colonies at OSU with sister queens from that year. So they're all brand new queens. They're all sister queens. because we never know if we're going to add some kind of research project at the last minute and stuff. So we have one bank that has those. And then we have kind of a hodgepodge. We raise our own queens too. So we bank our own queens in a separate bank. So we more than often have 3 banks going at a time, and we will only have a single banking frame in there, which holds, sometimes they're only holding 5 queens. Other times they're holding 60. So that's kind of to give you a range. You can, as long as you're managing those banks right, you can host a lot of queens in one bank.
I was just wondering, because you would think the number of queens that you have in there would be, well, naturally it'd be directly related to the strength of the colony and the number of nurse bees. Because if you have a bunch of queens that are caged in there, it would seem like they would take quite a bit of catering to.
Yeah, and that's definitely something to consider if you're overwintering queens. I do know some California beekeepers that will overwinter, 100 to 200 queens in a bank, but we're probably going to max out at 60 queens, what we want to evaluate here in Oregon.
Great, thank you.
Because of that reason, yeah, it's just, I feel like, yeah, it's a lot of mouths to feed. You have to have this really, really large cluster if you're going to have, 2 or 3 banking frames in there. So more risk.
Oh, great, Ellen. Thank you so much for your time and your presentation tonight. We really appreciate it.
Thanks for having